Hi, welcome back to Learn Buffalo in Go. Today we're going to talk about deploying your app with Docker. What are the benefits of using Docker to build and deploy our apps? With some cloud hosting providers, it may be easier to deploy inside Docker. You may also have other containers that you want to run alongside your app. Either way, it's not too hard to get started with Docker. The Buffalo CLI gives us a Docker file that we can use right away, or we can tweak and fine-tune it and run our application with that. Let's take a look. The Docker file that Buffalo gives us is a multi-stage build. What does that mean? If you're not familiar, a multi-stage build uses a sequence of containers, and each one is built with its own series of commands. For Buffalo, that means we have our first step is a Buffalo container that contains all of the Buffalo toolchain in order to build our app. That produces our binary, which is passed on to the second stage, and in that second stage we can specify a container that is better to run our web application in. By default it's using Alpine, which is a pretty slim Docker container. So we copy the binary into that new container, set some environment variables like our database URL, and then run a command or two in order to run the app. So that's great, but what if we wanted something other than Alpine to run our final application? We could make some minor changes to use Nginx, and that would give us more security and configuration to manage web requests. So we could change from Alpine to from Nginx, copy our Nginx configuration into the container, and do everything else we did before. Copy the binary, set our environment variables, and run our app. So what does this Docker file look like? This is a new project I created, and this is the Docker file that we get. This part is stage 1, where we use the Go Buffalo Buffalo container to build the app. And down here is stage 2, where we build our web application container. Here you can see the options for setting our environment variables. If you have a lot of variables in your .env file, you may want to add them here. One thing to notice down here is that we have two options for running our app. The first one, commented out, performs the migrate command before running the app. The second one just runs the app. In either case, you don't want both, you want one, so pick which one applies to your project. So how would we use Docker to run our Buffalo app? The first option would be to run our Buffalo app inside a Docker container all by itself. If we don't need to connect to an external database, then everything's good. If we need a database, we could try to connect to it on the host environment, or connect to a database running in another container somewhere. Another option would be to use something like Docker Compose, which helps us run multiple containers and manages the network interface in between them. So here we have Buffalo in one container, a database in another, and Docker Compose will help us manage the network connection between them. A third option is to put our Buffalo app inside a container and use a hosted database solution, something in the cloud, AWS or render.com, or some other hosting provider that basically has a URL that you can connect to for the database. In my experience, this first option does not work. When we put Buffalo inside a container and we expect it to understand what localhost database is or 127, it doesn't work. It cannot resolve the address to that database. Instead, I've had to use a cloud-hosted database, which, like I said, gives us a URL that we can use to pass to Buffalo. And as far as I understand, this issue relates to the underlying database toolset that Buffalo is using. It's not isolated to Buffalo. But if someone knows how to solve this, I would love to hear your solution. Another option to deploy your Buffalo app with Docker is to use a plugin like this one, the Buffalo Heroku plugin. This plugin streamlines a lot of the process for deploying your app into Heroku. It creates it as a containerized app, not a Go native app, but it will simplify a lot of the steps that you would have to do in Heroku to get that working. I think it's fair to say that it assumes you are using Heroku's official Postgres database to integrate with your app, so that is one limitation. Another option for using a cloud-hosted Postgres database is on render.com. This is similar to Heroku, a newer platform that has a hosted Postgres solution. You can create a database on Render and give it public access, and you can develop your app locally using the Postgres database hosted on Render. So just to take a look at how that works, I've created a Postgres database here on Render. And if we run the app locally, we can connect to that hosted Postgres database. So instead of running the Buffalo dev server, let's try to build a container with the default Docker file that we get. You can see I've run this before. It doesn't have to download a lot of the dependencies. It's just going to build our app. That's one of the benefits of Docker, is that it doesn't run layers that it doesn't need to run unless changes are detected. And so now that that container is built on my machine, I can try to run it. So now to run that image, we can do Docker run, and we have to map the ports to my local machine, 3000 to 3000, and we'll run that image. Okay, so it looks like everything's working. We are connecting to the database that's hosted in Render. These are those same two books that we had. At this point, we could push the image to a container registry and run it on a server that we have access to. Since we have our database running on render.com, we can also try to run the whole application from Render, and let's see what that looks like. Here in the Render dashboard, we have an option to connect to our GitHub account. Select the project, and here is where we can configure how we would run it. Now, the important thing here is that we want to run this as a Docker environment and not a native Go environment. When we do this, Render will build our Docker image, store it on its own container registry, and run the app from there. So let's jump over to look at an app I just created. Here we see the deployment logs, which are very similar to what we just ran on our local machine. And down here at the bottom, we get the confirmation starting application. We see the port 10,000. Render is going to set that for us. We don't need to worry about it. But the other environment variables are over here. Here we pass the database connection string, and we can also specify our Go environment using production. If we have other environment variables, we can set them here. When we open the app, here's what we get. And we can see it's also running on HTTPS, which is really nice. That's something that we don't have to manage here. So now we have our app running on render.com and our database running on Render, and everything works for us. The last piece I want to show is what if we wanted to use Docker Compose to run our app in a container and our database in a separate container, and how do we get around the problem with the database DNS resolution. So let's step through here. Again, we don't need to do anything special to our Docker file. We can set up our environment variables here, specify that we need to use the AppNet network that we're defining. Next is our database container, which will continue using Postgres. And here is the custom setup. So we can define the IP address of our database, which helps us get around the problem of the DNS resolution in the Go database tool set. And down here in the network, we can specify an IP range. So now when we run this from Docker Compose on our local machine, we should see that it works. So there you go. See, now this is using the database inside that containers, but that's a nice way to use Docker Compose to run our app locally. So that's a quick look at how we can run our Buffalo app inside of Docker. The Docker file we get by default from the Buffalo CLI will get us pretty far. We can make some minor tweaks if we needed to, but using Docker can be really helpful if we want to integrate with cloud hosting providers. We don't have to go through the process of setting up a server and configuring it. Docker gets us up and running pretty quickly. So that's it for now. Thanks for watching.